All right, in section 5.4, we're going to talk about the triangle midsegment theorem. So we're going to talk about the segment that's in the middle of a triangle. So here's what it looks like. This part right here is your definition. A midsegment of a triangle is a segment that joins the midpoints of two sides of a triangle. Every triangle has three midsegments, which form the midsegment triangle. So let's look at this. We have a black triangle PQR. Here's what happens. Here's what it does. If we connect the midpoints, I connected midpoints X, Y, and Z to make midsegments. Segment XY, segment YZ, and segment ZX. The midsegments form a triangle, which is called triangle XYZ. So it's a pretty easy overall understanding of what a midsegment would be. We just connect the midpoints, we make midsegments, three midsegments make a midsegment triangle. All right, example number 1. In triangle GHJ, show that the midsegment KL, which is the blue segment, is parallel to GJ. Right off the bat, parallel means we're going to have to find the slopes. The slopes will determine if they are parallel. Once we've done that, we have to now find the distances of those and prove that KL is half of GJ. So we have to do the distance formula and we have to do the slope. Here's the problem, and this is a big problem. I know you're going to look at K and be like, well, that's easy. Why can't I find slope and go up 2 over 4 and know my slope is 1/2? You could do that. The problem is you don't know that point. That point could be negative, let's see, 2, 3, 4, 5, 6. It could be negative 6.001. You don't know. So we have to find the midpoints first of the blue segment. So step 1, let's find the midpoints. So the midpoint, let's find K. We're going to add them together. So negative 5 and negative 7 gives us negative 12. Half of that is negative 6. I now take the 6 and the negative 2. That gives me 4. Half of that is 2. So negative 6, 2 is that. And midpoint L, do the same thing. Negative 5 and 1, that's negative 4. That gives me negative 2. 6 and 2 is 8. That gives me 4. So this one is negative 2, 4. So if you did find the slope, so I'm going to do this. The slope of KL, I'm just going to tell you right now, if you subtract them, you do get positive 1/2. The slope of GJ, if you subtracted or counted, it would give you, let's see, 2, negative 2 minus negative 2 would be 4, 4/8, and 4/8 is 1/2. So if you did find the slopes, they are the same. So we just showed that they're parallel. And why are they parallel? Because they have the same slope. The next step is using the distance formula. So I want to find the distance of KL. The distance of KL and the distance of GJ. So distance of KL, my points are here. So I subtract my x values, so negative 6 plus 2 would be negative 4 squared, plus 2 minus 4, which gives me negative 2 squared. That gives me 16 plus 4, which gives me the square root of 20. And the square root of 20 gives me, breaks down to square root of 4, square root of 5, which gives me 2 root 5, or 2 times the square root of 5. GJ, if I do the same thing, I subtract my x's, negative 7 minus 1 is negative 8. Negative 2 minus 2 is negative 4. That gives me 64 plus 16, which gives me the square root of 80. The square root of 80 breaks down into the square root of 16 and the square root of 5, which gives me 4 root 5. So GJ is 4 square root 5. KL is 2 square root 5. So, since 2 square root 5 is half of 4 square root 5, KL is half of GJ. And we just proved something. We just proved the triangle midsegment theorem. Here's what it says. A midsegment of a triangle is parallel to the side of a triangle. It should always be that way. And its length is always going to be half the length of the other side. Very important to notice. The midsegment and the other side are always going to be parallel, and it will always be half of the side. In example 2, we're going to use the triangle midsegment theorem to find the measure of two different things. Now, I've actually already given you the answers to show you how it's going to work. Once again, I would not expect you to show any of this work unless you're solving a proof, but I'm giving you this information in case you have to solve a proof. So UW, I want to find UW. Well, here's the great news. UW is going to be half of ST. So if you actually had to write that down, UW is half of ST because of the triangle midsegments theorem. We know ST is 7.4. All we have to do is substitute that in, take half of 7.4, and UW would be half of 7.4, which is 3.7. The measure of angle SVU, this angle right here is what we need to find. I'm going to mark that in blue. So this angle right here is what I need. SVU. That's a good TV show. SVU. UW is parallel to ST. Therefore, we know that if these are parallel, we have a transversal, and we know the measure of angle SVU is equal to the measure of angle VUW because alternate interior angles. Therefore, the measure of this angle right here has to also be 41 degrees. Our last example. Anna wants to find the distance across the base of Capelin Volcano, an extinct volcano in New Mexico. She measures a triangle at one side of the volcano as shown in the diagram. I would find it very hard to actually measure let's just measure the volcano. All right, well anyway, let's say she really did that. What is the length of AE? It should be very easy. We know what? Well, we know BD is half of AE. Substitution says that BD is 775 equals 1/2 of AE. And by multiplication property of equality, I multiply both sides by 2, and I get 1550 equals AE. So the distance across the base of the volcano is about 1,550 meters. The only vocab word you had today was the midsegment of a triangle.